We're going to look at a more functional skills style question. And remember, functional skills questions, they take different parts of our curriculum and put them together. And what we've got here is a question that involves bearings and some other stuff. So let's have a look. A sailing competition is marked out by 3 boys, A, B and C. B is 5 kilometers from A on a bearing of 260 degrees. C is 5 kilometers from A on a bearing of 160 degrees. The boats sail from A to B to C. And what bearing do they have to sail from B to C? Well, the first thing I notice is that both of the directions are given from A. That means in both cases we're thinking we're at A and we're turning from A to find the other boys. So let me mark on boy A first. I'm going to mark on north. I'm going to mark it on as straight up my page. So I'm told that B is 5 kilometers from A on a bearing of 260 degrees. This is a sketch to help me work this out. So 260 degrees, well, if 270 is due west, then 260 degrees is going to be a bit south, so a bit further anti-clockwise from that, so down from that. So there's B. So it is 5 kilometers. And so that angle is 260 degrees. I'm told C is 5 kilometers from A again, but in this case, it's 160 degrees. So 160 is going to be somewhere more than 90, less than 180, so somewhere down there, say. There's C, and that's going to be, again, 160 degrees. And we're asked for the bearing of of C from B. So let's see what we're going to do. So far, we know, let's mark in some of the angles. We know this angle here is 160 degrees. We know that altogether would be 160, and altogether that would be 260. So this white angle is going to be 100 degrees because those two angles together would be 260 degrees. And I'm being asked to find the bearing of C from B. So that means I'm standing north at B. What angle do I turn through to find C? So let's see, I'm going to connect B to C, and this is the angle I'm looking for. So I have a triangle. I have a triangle that has 2 equal sides, because this was 5 kilometers as well. Well, a triangle with 2 equal sides makes me think isosceles. And isosceles triangles have got the special property that the 2 base angles are equal. So if this is 100 degrees, then these 2 angles are going to be, well, 180 take 100, because the sum of angles in a triangle add to 180 is 80, and half it. So each of these are going to be 40 degrees. Oops, 40 degrees. And 40 degrees. So we have that bit. But there's another bit that we need. This other angle, this second angle here, is the angle that you would have to turn from B to face A. Well, let's see how we'd work that out. Here's B. Here's A. And to face B from A, we need to turn through 260 degrees. Well, we can see that this, to face due south, would be 180 degrees. So this angle here would be 260 take 180, which would be 80 degrees. And now we've got 2 parallel lines. So these are alternate angles, which means this angle and this angle are the same size. So that's 80 degrees. So our blue angle is 80 degrees. So our total bearing then, our bearing of C from B is going to be the 80 degrees to get to A and the extra 40 degrees to get to C. So the bearing that we're looking for is 120 degrees.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.